It is class Telugu physics students. In this class, we are going to learn about the electric field intensity due to a dipole. Here in this class, we will learn the electric field intensities along the axial line and as well as the equatorial. In previous edition of the video, we have learned that what is the dipole and what is the dipole moment. Once again, we will recall what is a dipole is. A dipole is nothing but the arrangement of the two charges, two different charges, at a fixed distance, students. Here it is representing a dipole. Take this, it is a negative charge and it is the positive charge being separated by a distance. This distance is equal to 2L. Well, students, and you have to remember that the dipole moment is nothing but intensity of the dipole, students. That is, it's a product of charge and the distance between the charges, students. There is a charge, one of the charges we are taking, and the distance between them is said as the dipole moment. Generally, this dipole moment is shown with the letter P bar. Here, dipole moment is a vector quantity, student. And you have to remember that the direction of the dipole moment, is from negative to positive, students. Not the positive to negative, but it is from negative to positive. It means the direction is certainly against the direction of the electric field. Generally, we learn that electric field is intensity. Is from positive to negative. Here, it is negative to positive, students. Let's say these two charges. We are finding the electric field intensity on axial line. Axial line means what? The line which is joining the two axes of the two charges. Okay. These two charges being separated by a distance which is equal to 2L, students. I said from the center it is the L and from here to here it is L. And it is a negative charge and it is a positive charge. And we are taking a charge which is at P. That means what? Unit charge by P. We are trying to find the field due to these charges at point P. Okay, students, the charge which is kept here or the point here experiences two forces due to the positive and as well as the negative. Here is the positive and take the positive charge here and a repulsion will act in between the two. But from this one to this, there could be a attraction. That means negative showing attraction on the charge which is kept at P and positive showing the repulsion. In that way, we can write the directions of the electric fields also, students. The direction of the electric field, say it is, I'm calling it as the A and the second is B. Okay, students, the direction of the electric field due to the bigger charge could be in this direction. I'm naming it as electric field due to B. Since it's a vector, it is written in that way. In the same way, here you know that it is the negative, that means positive charge, and it is the negative. The direction of the electric field due to the negative charge is in this direction. I'm calling it as a bar A. Okay, students. Then after we have to find out the electric field intensity due to this charge at the point P. Okay, students. We learned that electric field intensity is nothing but the amount of force acting on unit positive charge kept in a electric field. Okay, students. The amount of force acting on unit positive charge kept in a electric field. Here the magnitude can be had as E, and generally I am writing. Electric field intensity can be written as Q by 4 pi epsilon naught into R square. Is a formula for the electric field intensity, students. Or you can say the magnitude of electric field intensity can be had as Modulus of E bar is equal to Q by 4 pi epsilon naught into R square. R is the distance between the point and as well as the charge students. Here, if you want to find the electric field intensity between this one and point charge which is situated here. Okay, students, now we are going to find out the electric field intensity due to the two charges. Okay, at point P. Okay, watch this carefully. Here, it is the distance between the first charge A to B. Okay, students, let's say the point P is situated at a distance of R from the center of the dipole. Take it as R students. Okay, students. Then we have to measure the electric field intensity. What I told you, it is EA at this point. Now, the distance between this charge and the point charge situated here is R plus L students. In the same way, from here to here, it is R minus L students. I think you understood. This total distance is R and length of the, what is that? Half of the length of the dipole is equal to R. Okay, students. Then we are finding the electric field intensity, magnitude of the electric field intensity due to charge 1, EA bar, can be had as, this is a charge, I'm taking the magnitude, okay students, plus Q by 4 pi epsilon naught, and the distance is R plus L whole square. Okay, students, this is along P2A. This one is acting along P2A, students. Similarly, if you go with the second charge, that is P, intensity at this point can be had as a bar B is equal to Q by 4 pi epsilon naught, and the distance between the two is R minus L whole square. It is along, okay students, BB. Okay students, these two are the vectors actually. Then, if you ask them carefully, you will understand that the bar A is less than the bar B. Since this charge is very near to this, if you remember the Coulomb's law, you will understand that according to the second part of the Coulomb's law, okay, force decreases when the distance increases. Okay, so that's why we got A bar is less than AB bar. Okay, they are the collinear vectors, and we are going with the adding of the vector students. Here, AB is greater than A. Then we can write the resultant field modulus of E is equal to modulus of EB bar minus modulus of EA bar. Okay, students? EB bar is how much, students? The resultant E, I'm directly writing the magnitude. EB, we got it as Q by 4 pi epsilon naught into R minus L whole square minus Q by 4 pi epsilon naught into R plus L whole square. Okay, students. Then it can be written as, I'm taking Q by 4 pi epsilon naught as a common, and we'll find 1 by R minus L whole square minus 1 by R plus L whole square, students. Further, it can be written as Q by 4 pi epsilon naught into r plus L whole square minus r minus L whole square by r square minus L square whole square, students. Well, students, further it can be written as q by 4 pi epsilon naught into r square plus L square plus 2rl minus r square minus L square plus 2r by r square minus L square whole square, students. And further, r square L square get cancels and we get it as q by 4 pi epsilon naught into 4r L by r square minus L square whole square, students. Well, students, further we can write this equation as E resultant E is equal to q by 4 pi epsilon naught into, okay, here into 4rl by r square minus L square whole square. But we learn that P bar is equal to q multiplied with length, students, is 12. That is, the equation can also be written as q into 12 into 2r by 4 pi epsilon naught into r square minus L square whole square. Below that is p bar into 2r by 4 pi epsilon naught into r square minus L square whole square. It is the desired equation, students. Here we are making some corrections. Here for a dipole which is very small, I mean L is very much less than R. Then we are neglecting the term which is in the denominator, L square. Then what we get? It is P bar into 2R by 4 pi epsilon naught into R to the power of 4. R cancel and we get 2P bar by 4 pi epsilon naught into R. Okay, students, if you write in the vector notation, you can write magnitude of P bar is inversely proportional to 1 by R. It is the equation for the electric field intensity due to a dipole along the axial